For as long as humans have existed, we've accepted time's forward flow as natural as gravity or breathing. We plan for the future, remember the past, and experience the present as a moving boundary between what was and what will be. But here's what makes this deeply unsettling. Nothing in the fundamental laws of physics says time has to work this way. The equations that govern reality at its deepest level work perfectly well whether time moves forward or backward. Gravity, electromagnetism, the strong and weak nuclear forces, none of them care which direction time flows. Yet here we are, trapped in a universe where causes always precede effects, where entropy always increases, where the past is fixed and the future remains open. Tonight, we're going to uncover why time has an arrow, and what we discover will fundamentally change how you understand reality itself. We'll explore how a simple cup of coffee holds the key to one of physics' greatest mysteries. We'll discover why information might be more fundamental than energy or matter. We'll journey to the moment time itself was born and understand why that cosmic event locked us into our temporal prison. And we'll confront the terrifying possibility that time's arrow might not be as permanent as we think. The brilliant physicist Arthur Eddington first called this phenomenon time's arrow in 1927, recognizing that while space allows movement in any direction, time permits travel in only one. Since then, physicists have uncovered layer after layer of mystery surrounding this asymmetry. The second law of thermodynamics suggests time flows toward increasing disorder. Quantum mechanics reveals that observation itself might create time's direction. Cosmology shows us that time's arrow might be a cosmic accident, a byproduct of our universe's violent birth 14 billion years ago. But the deeper we dig, the stranger it gets. Recent discoveries in quantum mechanics suggest that the future might actually influence the past in ways we're only beginning to understand. Studies of consciousness reveal that our experience of time's passage might be fundamentally different from time itself. Research into information theory indicates that time's arrow might emerge from the universe's attempt to process and store information about its own states. What we're about to explore together challenges every assumption you've ever made about the nature of reality. We'll discover why remembering the past but not the future isn't just a limitation of human consciousness. It's baked into the fabric of existence itself. We'll understand why every process in the universe, from the nuclear fusion in stars to the firing of neurons in your brain, contributes to time's inexorable forward march. And we'll confront the possibility that time itself might not be fundamental at all, but rather an emergent property of something even more basic. If you're fascinated by the mysteries that govern reality at its deepest level, subscribe and hit the thumbs up button. And here is a question that will haunt you. If you could send just one message backward through time, what would it be? Comment below. I'll pin the most thought-provoking answer, because tonight we're going to understand why that message can never be sent. This journey will take us from the quantum realm, where particles seem to exist in multiple times simultaneously, to the edge of black holes where time itself breaks down, to the far future when the universe will have exhausted its ability to create new moments. We'll explore how your morning coffee demonstrates the same principle that powers stars and creates consciousness. We well understand why every photograph you've ever taken represents a victory over time's tendency toward chaos. But perhaps most importantly, we'll discover why time's forward flow isn't a limitation to endure, but rather the condition that makes existence, consciousness, and meaning possible in the first place. The arrow of time isn't our prison. It's the very thing that allows us to be. Now let's begin our journey into the heart of time's greatest mystery, starting with a broken symmetry that creates everything we know and love about reality. Chapter 1. Broken Symmetry. The most perfect snowflake you've ever seen started as a catastrophic failure of symmetry. High in the atmosphere, water molecules that should be dancing randomly in all directions suddenly break there, democratic chaos, and align in precise hexagonal patterns. This moment of broken symmetry, where equality gives way to direction, where randomness yields to order, reveals the fundamental principle behind time's arrow. Reality itself began with a symmetry breaking so profound that it created not just time's forward flow, but time itself. In the pristine mathematics that describe our universe's deepest laws, time enjoys perfect symmetry. Newton's equations work identically whether time flows forward or backward. Einstein's general relativity treats past and future as interchangeable directions through spacetime. The quantum mechanical wave function evolves with equal mathematical elegance in both temporal directions. If you filmed the collision of two elementary particles and played the movie in reverse, a physicist couldn't tell you which direction represents reality. The fundamental forces that shape existence at the smallest scales are completely time-symmetric. This creates what physicists call the arrow of time problem. If the laws of physics don't distinguish between past and future, why does every process in our actual universe clearly differentiate them? Why do we never see smoke gathering into cigarettes, ash reassembling into logs, or memories flowing from future to past? The mathematics suggests a universe where time could flow either way, yet we inhabit one where temporal direction is as fixed as the speed of light. The answer lies in understanding that symmetry breaking doesn't violate natural laws. It selects which of many mathematically possible realities we actually experience. Consider a pencil balanced perfectly on its point. The laws of physics treat every direction the pencil could fall as equally valid. But once it starts tipping, symmetry breaks and the pencil must fall in one specific direction. Similarly, our universe began in a state where time could flow either way, but through a cosmic symmetry breaking, it selected forward flow as the only direction we experience. This isn't merely an abstract mathematical curiosity. The broken symmetry that creates time's arrow is responsible for every meaningful process in existence. When a star forms from a collapsing gas cloud, it breaks the symmetry between dispersed matter and concentrated energy. When life emerges from chemical chaos, it breaks the symmetry between simple and complex organization. When consciousness arises from neural activity, it breaks the symmetry between random firing patterns and coherent information processing. The Nobel Prize-winning physicist Murray Gell-Mann demonstrated that what we call progress, whether in evolution, technology, or human understanding, is really a series of symmetry breakings that create irreversible directions through possibility space. Each time a symmetry breaks, it closes off certain paths through reality while opening others. Time's arrow isn't just the dimension along which change occurs. It's the mechanism that makes cumulative directional change possible in the first place. But here's where it gets mind-bending. The symmetry breaking that creates time's arrow might itself be an illusion created by our perspective within time. Recent work in theoretical physics suggests that from a truly fundamental viewpoint outside spacetime, perfect symmetry might still exist. What we experience as time's irreversible forward flow might be like watching a movie reel from inside the film. We see sequential scenes, but the entire movie exists simultaneously in a higher dimensional space. The physicist Carlo Rovelli has proposed that time's arrow emerges from our interaction with reality rather than being fundamental to reality itself. From this perspective, symmetry breaking isn't a cosmic event that happened once, but rather a continuous process that occurs every time any conscious observer makes a measurement or forms a memory. We don't live in a universe where symmetry was broken. We live as agents actively breaking symmetry with every moment of awareness. This suggests something profound about the relationship between consciousness and time. Perhaps the reason we experience time's arrow so vividly isn't because time objectively flows forward, but because consciousness itself is the mechanism through which symmetric possibility, space gets collapsed into asymmetric experienced reality. Every thought you think, every choice you make, Every memory you form might be contributing to the cosmic symmetry breaking that creates time's direction. To understand how this works in practice, imagine the universe as a vast phase space containing every possible arrangement of every particle, every possible state of every quantum field, every possible configuration of matter and energy. In this space, the laws of physics carve out allowed paths between states, but these paths run in both temporal directions. Symmetry breaking occurs when something, observation, measurement, the formation of information, selects specific paths through this space and gives them a preferred direction. You are not a passive observer riding time's current. You are an active participant in the symmetry breaking that creates time's arrow. Every photon that hits your retina, every neuron that fires in response to stimulus, every memory trace laid down in your brain contributes to the universal process that distinguishes past from future. The arrow of time doesn't carry consciousness along. Consciousness helps create the arrow of time. This revolutionary understanding transforms our relationship with temporal existence. We're not victims of time's irreversible flow. We're co-creators of the very asymmetry that makes flow possible. But to understand how this co-creation works, we need to explore the hidden mechanism that drives time's arrow, a fundamental tendency toward disorder that permeates every corner of reality. The broken symmetry that creates time's direction is about to reveal its most profound secret, one that connects the cooling of your coffee to the death of stars and the emergence of consciousness itself. Chapter 2. Hidden Arrow. In 1865, a German physicist named Rudolf Clausius made an observation that would revolutionize our understanding of time forever. While studying steam engines, he discovered a fundamental principle hiding in plain sight. Energy spontaneously flows from hot objects to cold ones, but never the reverse. Ice cubes melt in warm water, but warm water never spontaneously freezes around ice cubes. This simple observation revealed the existence of a hidden arrow embedded in the fabric of reality. Entropy always increases, and this increase defines the forward direction of time. Entropy is often described as disorder, but this description barely captures its profound implications for temporal existence. Entropy is actually a measure of how many microscopic arrangements can produce the same macroscopic state. A perfectly ordered crystal has low entropy because there's only one way to arrange its atoms to achieve that perfect structure. A gas filling a room has high entropy because there are countless ways to arrange its molecules while maintaining the same overall appearance. The second law of thermodynamics states that in any isolated system, entropy never decreases. This isn't just a tendency or statistical preference. It's an iron law that governs every process in the universe. When entropy increases, information about the system's past gets scrambled and lost. When you mix cream into coffee, the molecules spread and intermingle in ways that erase all traces of their previous separation. The energy required to unmix them isn't just unavailable. The information needed to guide that unmixing has been permanently destroyed. This destruction of information is what creates time's arrow. The physicist James Clerk Maxwell illustrated this with a famous thought experiment. Imagine a microscopic demon who could track every molecule's position and velocity with perfect precision. Such a demon could theoretically reverse any entropic process by sorting fast molecules from slow ones, hot regions from cold ones, organized states from chaotic ones. But here's the crucial insight. The demon would need to store information about each molecule, and the act of storing that information would itself increase entropy. Time's arrow emerges from the fundamental impossibility of perfect information preservation. The hidden arrow of entropy operates at every scale of reality. In your brain, memories form when neural connections strengthen in response to experience, increasing the entropy of your nervous system's configuration space. Stars shine by converting simple hydrogen into complex, heavier elements, increasing the entropy of atomic structure throughout the universe. Life itself exists by accelerating entropy increase in its environment. Organisms maintain their internal order by creating greater disorder in their surroundings through metabolism and waste production. But entropy's relationship with time is far more subtle than simple disorder accumulation. The physicist Ludwig Boltzmann realized that entropy increase isn't fundamentally about energy dissipation. It is about the expansion of possibility space. Every time a system transitions from a low entropy state to a high entropy state, it moves from a configuration that could have been reached in few ways to one that could be reached in many ways. This transition is irreversible not because energy is lost, but because the system has entered a region of possibility space too vast to escape. Consider a deck of cards in perfect order, from ace to king in all four suits. This represents an extremely low entropy state because there's only one arrangement that produces this specific order. Now shuffle the deck once. The resulting arrangement represents a higher entropy state because there are many more ways to arrange cards randomly than in perfect order. To return to the original sequence, you would need to navigate through the vast space of all possible arrangements and find that one specific path back to perfect order. A task so improbable, it is effectively impossible. The universe began in an extraordinarily low entropy state, a hot, dense, highly ordered configuration where all matter and energy were compressed into a volume smaller than an atom. The Big Bang represents the moment this cosmic deck of cards began shuffling, and everything that has happened since represents entropy's inexorable increase. Galaxies formed as gravity-amplified tiny density fluctuations. Stars ignited as gravitational collapse converted potential energy into heat. Life emerged as chemical processes found ways to accelerate local entropy increase while temporarily maintaining internal organization. This cosmic perspective reveals why time's arrow feels so fundamental to human experience. We aren't just observers of entropy increase. We are entropy increase. Every thought you think represents your brain transitioning from one neural configuration to another, increasing the total entropy of your nervous system. Every memory you form adds to the accumulated information about your past experiences, expanding your personal entropy space. Every choice you make selects one path through possibility while closing off others, contributing to the universe's irreversible journey toward maximum entropy. The physicist Sean Carroll has shown that the arrow of time emerges from this entropic foundation in three distinct but connected ways. First, the thermodynamic arrow points from low entropy to high entropy. Second, the psychological arrow points from memories of the past to expectations of the future. Third, the cosmological arrow points from the Big Bang toward the heat death of the universe. These are separate phenomena. They read different manifestations of entropy, as hidden arrow piercing through every level of reality. But here's where the mystery deepens. While entropy always increases in the universe as a whole, local regions can experience temporary entropy decreases. Your body maintains its organized structure by consuming food and exporting waste, creating a pocket of decreased entropy surrounded by greater entropy increase in your environment. Life represents billions of years of evolution, discovering increasingly sophisticated ways to decrease local entropy while accelerating global entropy increase. This raises a profound question. If entropy's arrow creates time's forward direction, what happens in regions where entropy temporarily decreases? Some physicists propose that local time reversal might actually occur in highly organized systems, but these reversed temporal regions would be causally disconnected from the broader universe. Others suggest that apparent entropy decreases are actually entropy increases, viewed from a broader perspective that includes information about the system's environment. The hidden arrow of entropy reveals time's direction as an emergent property of information processing, rather than a fundamental feature of spacetime geometry. Time flows forward because the universe is constantly processing information about its own states, and this processing necessarily increases the total information content, while decreasing the retrievability of past information. We experience time's passage as the continuous conversion of accessible past information into inaccessible future possibilities. Understanding entropy's role as time's hidden arrow transforms our relationship with temporal existence. We're not moving through time. We are time, in the sense that our consciousness represents the universe's ongoing process of converting organized information into dispersed entropy. But to grasp the full implications of this insight, we need to explore how this hidden arrow operates in the grandest kitchen of all, the entire cosmos. Chapter 3. Cosmic Kitchen. Imagine the universe as an enormous kitchen where 13.8 billion years ago, someone turned on the heat under a pot, containing every particle, every force, and every possibility that would ever exist. Since that moment, this cosmic kitchen has been following the same basic recipe that governs your morning coffee cooling on the counter. Energy spreads out, temperatures equalize, and hot spots gradually surrender their heat to cooler regions. The universe isn't just expanding, it's cooling, and this cosmic cooling process is what creates the thermodynamic foundation for time's arrow throughout all of reality. The Big Bang wasn't an explosion in space. It was the sudden appearance of space itself, along with time, matter, energy, and the fundamental forces. In those first fractions of a second, the entire observable universe was compressed into a region smaller than a proton, with temperatures exceeding 100 billion degrees Kelvin. This represents the ultimate low entropy state, maximum energy density in minimum volume, with perfect thermal equilibrium and no temperature gradients. Everything was the same temperature, the same density, the same perfect cosmic soup. But here's what makes this the ultimate thermodynamic puzzle. Perfect equilibrium should be stable. If everything in the universe was at the same temperature with no energy gradients, no forces driving change, how did anything ever happen? The answer reveals the most profound aspect of time's arrow. It doesn't emerge from equilibrium. It emerges from the breaking of equilibrium. The cosmic kitchen began cooking, not because someone added heat, but because expansion itself created temperature differences where none existed before. As the universe expanded, it didn't just grow larger, it grew cooler. This cooling happened for the same reason that compressed air feels cold when released from a pressurized container. The expansion did work against the internal pressure of space itself, converting thermal energy into the energy of expansion. Within the first microsecond, the universe had cooled enough for fundamental forces to separate from their unified high-energy state. Gravity became distinct from electromagnetism. The strong nuclear force separated from the weak force. These symmetry breakings weren't just changes in physical law. They were the first steps in the cosmic cooking process that would eventually create stars, planets, and consciousness itself. The physicist Alan Guth discovered that during an infinitesimally brief period called cosmic inflation, the universe expanded faster than the speed of light itself. This inflation stretched tiny quantum fluctuations in energy density across vast regions of space, creating the temperature variations that would later become galaxies, stars, and all large-scale structure. These fluctuations were incredibly small, variations of only 1 part in 100,000, but they represented the first emergence of spatial temperature gradients in cosmic history. These primordial temperature differences became the ingredients for everything that followed. Slightly denser, slightly cooler regions began attracting matter through gravitational collapse. As matter fell into these gravitational wells, gravitational potential energy converted into kinetic energy, then into thermal energy through collisions. The cosmic kitchen had discovered fire, the process of gravitational heating that would power structure formation for billions of years. The formation of the first stars represents the universe learning to cook with nuclear fusion. When gravitational collapse compressed hydrogen clouds beyond critical density and temperature, nuclear reactions began converting hydrogen into helium while releasing tremendous amounts of energy. These stellar furnaces created the first significant temperature gradient since the Big Bang, establishing hot stellar interiors surrounded by the cold vacuum of space. Stars are essentially cosmic stoves, burning nuclear fuel to maintain temperature differences that drive complex chemistry throughout the universe. But stellar cooking does more than just create heat. It creates the heavy elements essential for complex structure. Inside stellar cores, nuclear fusion forges carbon, nitrogen, oxygen, and all elements up to iron through successive burning phases. When massive stars exhaust their nuclear fuel, they explode as supernova, creating elements heavier than iron and distributing this atomic complexity throughout space. The cosmic kitchen gradually shifts from a simple hydrogen and helium broth to a rich mixture containing all the ingredients necessary for rocky planets, organic chemistry, and life. The emergence of planetary systems around stars creates new scales of thermal complexity. Planets develop atmospheric and geological processes that create their own temperature gradients and energy flows. On Earth, the combination of solar heating, radioactive decay, and gravitational energy drives plate tectonics, weather patterns, ocean currents, and all the geological processes that shape planetary environments. The cosmic kitchen has learned to prepare many different dishes simultaneously, each with its own thermal characteristics and temporal evolution. The most extraordinary cooking achievement in cosmic history occurred when self-replicating chemical systems emerged from the temperature gradients and energy flows created by stellar heating of planetary environments. Life represents the universe learning to cook with information, using energy gradients to create, maintain, and reproduce complex molecular structures that process information about their environment. Biological evolution is essentially a 4 billion year cooking experiment in which natural selection continuously refines recipes for converting environmental energy into organized complexity. The development of consciousness adds another layer to the cosmic kitchen's capabilities. Brains are sophisticated thermal engines that convert chemical energy from food into the electrical and thermal energy needed for information processing. The approximately 20 watts of power consumed by a human brain generates complex patterns of neural activity that can model, predict, and manipulate environmental energy flows. Consciousness represents the cosmic kitchen becoming aware of its own cooking processes. But the cosmic kitchen operates under strict thermodynamic constraints that determine its ultimate fate. The second law of thermodynamics guarantees that all temperature differences will eventually equilibrate, all energy gradients will flatten, and all nuclear fuel will be exhausted. Stellar formation peaked approximately 10 billion years ago and has been declining ever since as the universe consumes its stellar fuel reserves. In approximately 100 trillion years, the last stars will burn out, leaving behind only white dwarfs, neutron stars, and black holes slowly cooling in an ever-expanding, ever-darkening universe. This cosmic heat death represents the final equilibrium state toward which all cooking processes ultimately tend. Temperature differences will disappear, chemical reactions will cease, and the arrow of time will effectively stop because no further entropy increase will be possible. The cosmic kitchen will have completely cooled, its cooking permanently finished. But this distant fate reveals something profound about time's relationship with temperature gradients and energy flows. The arrow of time exists only as long as the universe remains far from thermal equilibrium. Time as direction emerges from the cosmic cooking process, from the universe's ongoing conversion of organized energy into dispersed heat. We don't experience time passing because we're moving through some external temporal dimension. We experience time passing because we're participating in the universe's approach toward thermal equilibrium. This cosmic perspective explains why time feels fundamentally different from space. While we can move freely in any spatial direction, we're carried inexorably forward in time because we're embedded in the universe's thermodynamic evolution. The cosmic kitchen isn't just our environment, It is the process that creates and maintains our existence. Every breath we take, every thought we think, every action we perform represents a tiny contribution to the universe's overall approach toward thermal equilibrium. Understanding the universe as a cosmic kitchen transforms our relationship with time and existence. We're not separate from the thermodynamic processes that create time's arrow. We are those processes, organized into temporary patterns of complexity that accelerate the cosmic cooking while briefly maintaining our own internal organization. But to understand how this cosmic cooking creates the specific temporal phenomena we experience daily, we need to explore the quantum realm, where the very act of observation itself contributes to time's forward flow. Chapter 4: Quantum Ghosts. In the subatomic realm, where quantum mechanics governs reality, time becomes something far stranger than our everyday experience suggests. Here, particles exist in multiple states simultaneously until observation collapses them into definite properties. Information travels backward through time in ways that seem to violate causality. The future appears to influence the past, and measurement itself seems to create the temporal relationships we observe. These quantum ghosts of possibility and actuality reveal that time's arrow at the smallest scales emerges not from physical processes, but from the mysterious relationship between information, observation, and reality itself. The quantum world operates according to rules that seem to completely violate our temporal intuitions. When a photon travels through a double-slit apparatus, it somehow knows whether both slits are open before it decides whether to behave as a wave or particle. The physicist John Wheeler demonstrated this with his delayed choice experiment, where the decision about how to measure a photon can be made after the photon has already passed through the apparatus. Somehow, the future measurement retroactively determines the photon's past behavior, suggesting that quantum causality can flow backward through time. But the most mind-bending aspect of quantum temporal mechanics involves what physicists call quantum superposition. At the quantum scale, particles don't have definite properties until they reobserved. They exist in ghost-like states of all possible properties simultaneously. Schrodinger's famous cat thought experiment illustrates this strangeness. Until observation collapses the quantum superposition, the cat exists as a ghost-like combination of alive and dead states. Time itself seems to be in superposition at the quantum scale, with events existing in combinations of happened and didn't happen until observation forces them into definite temporal relationships. The Nobel Prize-winning physicist Werner Heisenberg discovered that this quantum uncertainty isn't just a limitation of our measurement capabilities. It's fundamental to reality itself. The uncertainty principle states that certain pairs of properties, like position and momentum or energy and time, cannot be simultaneously determined with perfect precision. This time-energy uncertainty relationship means that quantum events can borrow energy from the vacuum for brief periods, creating virtual particles that pop into existence and disappear before the universe's accounting system notices the violation. These quantum fluctuations create what physicist John Wheeler called quantum foam, a seething sea of virtual particles constantly appearing and disappearing at the smallest scales of spacetime. This foam suggests that time itself might not be smooth and continuous as it appears to our macroscopic experience, but rather granular and discrete at scales smaller than the Planck time, approximately y-43 seconds. Below this scale, the very concept of temporal sequence breaks down into quantum uncertainties. The process of quantum measurement reveals time's most mysterious property: the conversion of ghostly possibilities into definite actualities. When a quantum system interacts with a measurement apparatus, its wave function describing all possible states collapses into one specific outcome. This collapse seems to happen instantaneously, faster than light could travel between distant parts of the quantum system. Einstein called this spooky action at a distance, but modern experiments have confirmed that quantum entanglement really does create instantaneous correlations across arbitrary distances. But here's what makes quantum measurement so crucial for understanding time's arrow. The collapse of the wave function is irreversible. Once a quantum measurement has occurred, the information about the system's previous superposition state is permanently lost. The quantum ghost dissolves into classical reality, and there's no way to recover the specific combination of possibilities that existed before measurement. This irreversible loss of quantum information contributes to entropy increase and helps create time's forward direction. The physicist Hugh Everett III proposed a radical solution to the measurement problem that has profound implications for time's nature. According to the many worlds interpretation, quantum measurements don't actually collapse wave functions. Instead, they create parallel branches of reality where every possible measurement outcome actually occurs. From this perspective, quantum ghosts never disappear. They just become isolated in separate timeline branches that can no longer communicate with each other. If many worlds is correct, then time's arrow emerges from the continuous branching of reality rather than from the destruction of quantum possibilities. Every quantum measurement creates new parallel timelines, each with its own version of observers who experience their branch as the real timeline while remaining oblivious to all others. The arrow of time points in the direction of increasing parallel realities, with the total number of timeline branches growing exponentially as quantum events accumulate throughout the universe. Recent experiments in quantum mechanics have revealed even stranger temporal phenomena. Scientists have achieved quantum time travel by sending photons through quantum systems that simulate closed time-like curves. In these experiments, photons can interact with their past selves in ways that remain logically consistent but violate our normal understanding of causality. The photons seem to negotiate with their past selves to ensure that no paradoxes occur, suggesting that quantum mechanics might contain built-in mechanisms for maintaining causal consistency, even when time loops exist. The physicist Paul Davies has shown that black holes create the most extreme quantum temporal effects in the known universe. Near a black hole's event horizon, quantum fluctuations in the vacuum become separated by the intense gravitational field. Virtual particle pairs that normally annihilate each other get pulled apart, with one particle falling into the black hole while the other escapes as Hawking radiation. This process seems to violate conservation of information, creating a quantum ghost called the information paradox that haunts theoretical physics. Some scientists propose that the information paradox reveals something fundamental about time's relationship with quantum mechanics. Perhaps the information that falls into black holes doesn't disappear, but gets encoded on the black hole's surface in a holographic manner. From this perspective, three-dimensional space and time might be projections of more fundamental two-dimensional information stored on cosmic surfaces. Reality's quantum ghosts might be shadows cast by this deeper informational reality. The emerging field of quantum information theory suggests that time's arrow ultimately emerges from the universe's processing of quantum information, rather than from classical thermodynamic processes. Every quantum measurement represents the conversion of potential information into actual information, and this conversion creates the irreversible increase in total information that we experience as time's forward flow. Consciousness might play a special role in this process, as conscious observers seem uniquely capable of collapsing quantum superpositions through observation. But quantum consciousness theories propose an even more radical possibility, that consciousness itself might be a quantum process that exists partially outside normal spacetime. Some models suggest that conscious experiences occur in quantum superposition states that are not subject to normal temporal constraints. From this perspective, the subjective experience of time's flow might emerge from consciousness navigating between different quantum possibility states rather than moving through objective temporal dimensions. The quantum realm reveals that time's arrow operates through mechanisms far more subtle than simple entropy increase or information loss. At the deepest level, time's direction might emerge from the universe's ongoing conversation between quantum possibilities and observed actualities. We aren't just passive observers writing time as current. We're reactive participants in the quantum measurement process that creates time's direction through the continuous conversion of ghostly possibilities into definite realities. Understanding quantum ghosts and their relationship with time's arrow prepares us to explore how this conversion of possibility into actuality creates the phenomenon of memory, the mechanism through which conscious beings participate in time as forward flow by crystallizing experiences into permanent information structures. Chapter 5. Memory Crystals. Your brain contains approximately 86 billion neurons, each connected to thousands of others through synapses that strengthen and weaken based on experience. Every memory you form crystallizes a specific pattern of neural connections into a semi-permanent structure that preserves information about past events. These memory crystals aren't just passive recordings. They read the biological mechanism through which consciousness participates in creating time. Arrow by converting transient experiences into permanent information structures that can only accumulate, never decrease. Memory represents one of the most profound connections between consciousness and time's directional flow. While you can imagine moving your body through space in any direction, you cannot move your consciousness backward through the sequence of your memories. You remember the past, but not the future. Know what happened, but not what will happen. Can retrieve information about yesterday, but not about tomorrow. This asymmetric access to temporal information isn't a limitation of human cognition. It is a direct consequence of how memory formation contributes to entropy increase throughout the universe. The process of forming memories requires energy to strengthen synaptic connections between neurons. And this energy expenditure increases the entropy of your brain's environment. When you experience something memorable, a conversation, a scene, a new idea, your nervous system converts the temporary electrical patterns of neural activity into more permanent changes in synaptic strength and protein synthesis. This conversion from dynamic activity to structural change represents the biological version of entropy increase, transforming reversible neural processes into irreversible memory traces. But memory formation does more than just increase entropy. It creates information about information. Your memory of reading these words isn't just a record of the photons hitting your retina or the neural patterns they triggered. It's a compressed representation that preserves the meaning and significance of this experience while discarding irrelevant details. This compression process necessarily loses information about the original experience, making perfect memory retrieval impossible and memory formation irreversible. The physicist John Wheeler proposed that information might be more fundamental than matter, an energy that the universe might be in a bit system where physical reality emerges from underlying informational processes. From this perspective, memory crystals represent localized information processing systems that participate in the universe as overall conversion of potential information into actual information. Every memory you form contributes to the cosmic increase in total information content while making some aspects of past information irretrievable. The temporal asymmetry of memory extends far beyond human consciousness. DNA molecules in every living cell function as molecular memory crystals that preserve information about evolutionary history. Each gene represents compressed instructions for building biological structures, accumulated over billions of years through natural selection. Mutations add new information to genetic memory while occasionally corrupting or losing old information, creating the irreversible evolutionary arrow that connects simple early life to complex modern organisms. Geological formations act as Earth's memory crystals, preserving information about past environmental conditions in rock layers, ice cores, and sediment deposits. The radioactive decay of unstable isotopes creates natural clocks that record the passage of time in atomic memory crystals, with each decay event representing an irreversible transition that can never be undone. These geological and radiological memory systems demonstrate that information accumulation and time S-arrow operate at every scale from atoms to planets. Even the cosmic microwave background radiation that fills the universe functions as a vast memory crystal preserving information about the Big Bang. This ancient light carries detailed information about the density fluctuations that existed when the universe was only 380,000 years old, encoded in tiny temperature variations across the sky. These cosmic memory patterns reveal how the universe's first information structures evolved into the galaxies, stars, and planets we observe today. But memory crystals don't just preserve information. They create the subjective experience of time's passage through the process of memory retrieval and comparison. When you remember something, your brain reconstructs an approximation of the original experience using current neural patterns. This reconstruction necessarily differs from the original experience, creating a sense of temporal distance between past and present. The subjective feeling of time's flow emerges from consciousness continuously, comparing current experiences with memory reconstructions of past experiences. The neuroscientist Endel Tolving discovered that human memory operates through multiple systems with different relationships to time. Episodic memory preserves information about specific events with their temporal context, allowing you to remember not just what happened, but when it happened. Semantic memory stores factual information without temporal context, allowing you to know that Paris is the capital of France without remembering when or where you learned this fact. Working memory maintains current information for immediate use without creating permanent storage. These different memory systems create different types of temporal experience, from the vivid reliving of episodic memories to the timeless access of semantic knowledge. Recent research reveals that memory formation involves the active forgetting of irrelevant information as much as the preservation of relevant details. Your brain continuously decides what information to crystallize into permanent memory and what to allow to fade. This selective preservation process requires energy expenditure and creates entropy increase, contributing to time's arrow while shaping your personal narrative about past experiences. Forgetting isn't a failure of memory. It is an essential mechanism that prevents information overload while maintaining the irreversible accumulation of meaningful experience. The relationship between memory and consciousness becomes even more complex when considering false memories and confabulation. Your brain can create vivid memories of events that never occurred, and these false memory crystals feel subjectively identical to memories of real experiences. This suggests that consciousness doesn't just preserve information about past experiences, it actively constructs narratives about the past using both actual memories and imagination. The subjective arrow of time emerges not just from objective information accumulation, but from consciousness actively creating coherent stories about temporal experience. The phenomenon of déjà vu reveals how memory systems can create temporary disruptions in time's arrow. During déjà vu experiences, current experiences trigger false familiarity that makes the present feel like a remembered past. Some researchers propose that déjà vu occurs when memory formation processes temporarily malfunction, creating the illusion that current experience has already been crystallized into memory. These glitches in temporal processing demonstrate how dependent our normal sense of time's flow is on proper memory function. Patients with anterograde amnesia, who cannot form new memories after brain damage, experience a profound disruption in their relationship with time's arrow. While they retain memories formed before their injury, they cannot create new memory crystals to mark the passage of time after the damage occurred. For these patients, subjective time effectively stops flowing forward. They remain trapped in the temporal moment when their memory formation ability was lost. This condition reveals how essential memory formation is for normal temporal experience. The development of external memory systems, from written language to digital storage, represents humanity's attempt to create artificial memory crystals that transcend biological limitations. These external information storage systems preserve human knowledge and cultural information across generations, creating collective memory crystals that accumulate information over historical timescales. The Internet represents the largest memory crystal ever created, storing and organizing human information in ways that accelerate the global accumulation of knowledge while making vast amounts of past information instantly accessible. But external memory systems also reveal new aspects of time's arrow. Digital information can be perfectly copied without degradation, potentially violating the normal entropy increase associated with information storage. However, the energy required to maintain digital storage systems and the heat generated by computation ensure that even perfect information copying contributes to overall entropy increase in the physical systems that support digital memory. Understanding memory as crystallized information reveals consciousness as an active participant in creating time's arrow rather than a passive observer of its effects. Every memory you form, every fact you learn, every experience you preserve contributes to the universe's irreversible accumulation of information. Your personal timeline exists as a collection of memory crystals that can only grow, never shrink, creating your subjective experience of moving forward through time. But to understand why this forward motion feels like an inescapable prison rather than a choice, we need to explore the causal structures that lock consciousness into temporal trajectories from which there is no escape. Chapter 6. Causal Prison. Right now, you are trapped in a causal prison with no possibility of escape. Every action you take, every decision you make, every thought you think is constrained by an invisible network of causal relationships that extend backward to the Big Bang and forward to the heat death of the universe. You cannot step outside this causal structure any more than you can step outside space itself, because causality is the fundamental architecture that creates temporal sequence and makes coherent reality possible. The arrow of time doesn't just flow forward. It creates a causal prison that locks every event into its proper temporal position. Causality seems like the most obvious aspect of existence. Causes precede effects. Actions have consequences. Events unfold in logical sequence from conditions to outcomes. But this apparent simplicity conceals one of physics' deepest mysteries. Why does causality work this way? The fundamental equations of physics are time reversible, meaning they work equally well with causes following effects as with effects following causes. Yet we never observe reversed causality in our actual experience. Lightning never uncreates the thunder it caused. Shattered glass never spontaneously reassembles into whole windows. Effects never reach backward through time to prevent their causes. The philosopher David Hume pointed out that we never actually observe causality itself. We only observe temporal sequences of events and infer causal relationships between them. When one billiard ball strikes another, we see the first ball moving, then contact, then the second ball moving. We interpret this sequence as causation, but Hume argued that causality might be a mental construct we project onto reality rather than an objective feature of the physical world. Modern physics has vindicated Hume's skepticism in unexpected ways while revealing that causal structure is even more fundamental than he imagined. Einstein's theory of relativity revolutionized our understanding of causal structure by revealing that simultaneity is relative while causal order remains absolute. Two events that appear simultaneous to one observer might occur in different temporal order for an observer in relative motion, but no observer can ever see an effect occurring before its cause. The speed of light creates an absolute limit on causal influence. Information cannot travel faster than light, So causes cannot affect events beyond their light cone of possible influence. This creates a cosmic causal structure, where every event has a precisely defined region of spacetime that it can influence and another region from which it can be influenced. But relativity reveals something even more profound about causal structure. The past and future do not exist as separate realms connected by causal flow. Instead, all events throughout spacetime exist simultaneously in what physicists call the block universe or eternalist view of time. From this perspective, causality doesn't create temporal sequence. Causality is temporal sequence. The causal relationships between events define their temporal ordering rather than occurring within some pre-existing temporal framework. This block universe view suggests that your sense of moving forward through time is an illusion created by your embedded perspective within causal structure. You don't move through time. You exist as a four-dimensional object extended through spacetime, with different temporal cross-sections of this object corresponding to your experiences at different moments. The causal prison isn't something that traps you within time. It's the structure that creates your temporal existence in the first place. The quantum mechanical version of causal structure becomes even stranger. In quantum field theory, virtual particles can propagate backward through time as antiparticles propagating forward through time. This mathematical equivalence suggests that the quantum vacuum seethes with causal loops where effects reach backward to influence their own causes. These closed causal curves don't violate causality. They represent the deeper level of causal self-consistency, where the universe negotiates with itself to maintain logical coherence even when events influence their own preconditions. The physicist Kip Thorne has shown that general relativity permits the existence of closed time-like curves where massive objects could theoretically travel backward through time and interact with their past selves. But these time loops come with built-in causal consistency requirements that severely constrain what changes are possible. Any attempt to create a grandfather paradox, preventing your own birth by changing the past, triggers quantum mechanical effects that preserve causal consistency. The universe seems to have built-in mechanisms that prevent causality violations even when the geometry of spacetime permits time travel. Recent work in quantum information theory reveals that causal structure might be even more fundamental than spacetime itself. The physicist Lucien Hardy has shown that quantum mechanics can be derived from basic principles about information processing and causal structure without reference to space or time. From this perspective, spacetime emerges from underlying causal relationships between information processing events rather than providing the stage upon which causal relationships play out. This informational approach to causality suggests that the causal prison exists at the most basic level of reality, not just as a feature of macroscopic physics, but as the fundamental principle that makes physics itself possible. Every quantum measurement represents a causal event that processes information about previous quantum states while generating information that influences future measurements. The network of these causal relationships creates the apparent temporal sequence of quantum events. But the most surprising aspect of causal structure is that it permits genuine choice and free will, despite creating an inescapable prison. The causal prison doesn't predetermine your actions. It provides the framework within which your choices become physically real and consequential. Every decision you make represents a genuine causal intervention that changes the universe's trajectory through possibility space. Your choices matter precisely because they're embedded within causal structure that transmits their consequences forward through time. The neuroscientist Benjamin Libet's famous experiments seem to show that unconscious brain activity precedes conscious decisions by several hundred milliseconds, suggesting that free will might be an illusion. But subsequent research has revealed that conscious intention can modify or veto actions initiated by unconscious processes. The causal prison doesn't eliminate choice. It creates the temporal framework within which choices can have meaningful consequences that persist beyond the moment of decision. The relationship between consciousness and causal structure reveals why the arrow of time feels like forward motion rather than static existence. Consciousness operates by forming expectations about future events based on information about past events, creating a subjective sense of moving from known past toward unknown future. This temporal asymmetry in conscious access to information creates the experience of flowing forward through time, even though your entire temporal existence might be eternally present in the block universe. The computer scientist Scott Aronson has shown that the computational complexity of predicting the future differs fundamentally from the complexity of retrodicting the past. Given complete information about a system's current state, calculating its past states is generally much easier than calculating its future states. This computational asymmetry creates a natural arrow of time for any information processing system embedded within causal structure, including conscious brains. The causal prison also explains why time travel stories inevitably involve paradoxes and logical contradictions. Any attempt to change the past must confront the fundamental causal consistency of the universe. Even if you could travel backward through time, your actions in the past would be constrained to produce exactly the history you already know occurred. The causal prison extends through all of space-time, creating a logically self-consistent structure where every event contributes to producing the conditions necessary for its own occurrence. Understanding the causal prison reveals why the arrow of time feels simultaneously constraining and liberating. You cannot escape the forward flow of causality any more than you can escape the three dimensions of space. But this constraint is precisely what makes meaningful action possible. Without causal structure, your choices would have no consequences and your experiences would lack coherent sequence. The causal prison isn't a limitation on freedom. It's the precondition that makes freedom meaningful. But to understand how this cosmic causal structure manifests in our everyday experience, we need to explore how entropy and decay operate at every scale throughout the universe, creating the universal tendency toward disorder that drives time's arrow from quantum events to galactic evolution. Chapter 7. Universal Decay. Every atom in your body is slowly decaying. The carbon atoms that form your DNA have been counting down toward radioactive decay for billions of years, with each atom having a 50-50 chance of transforming into nitrogen every 5,730 years. The protons in your cells, once thought to be perfectly stable, might themselves decay over timescales so vast they dwarf the current age of the universe. From the quantum foam of virtual particles to the eventual evaporation of black holes through Hawking radiation, every structure in the universe participates in the cosmic process of decay that drives time's arrow at all scales of reality. Radioactive decay represents the most precise manifestation of time's arrow in the physical world. When a uranium-238 nucleus randomly emits an alpha particle and transforms into thorium-234, this event creates an irreversible change that can be detected and measured with extraordinary precision. The decay process follows quantum mechanical probabilities but produces macroscopically observable consequences, creating a bridge between the reversible equations of fundamental physics and the irreversible arrow of time we experience in daily life. The randomness of quantum decay events reveals something profound about time's relationship with probability. While individual decay events are completely unpredictable, large collections of radioactive atoms decay with statistical regularity that allows precise measurement of half-lives spanning from microseconds to billions of years. This combination of quantum randomness and statistical predictability creates a cosmic clock that has been running since the Big Bang, with different radioactive isotopes serving as temporal markers for different eras in cosmic history. But radioactive decay is just the most obvious example of universal decay processes. The spontaneous fission of heavy atomic nuclei demonstrates that even the strongest force in nature, the nuclear force that holds protons and neutrons together, cannot indefinitely resist the decay tendency built into the fabric of reality. Neutron stars, the densest stable matter in the universe, slowly cool through neutrino emission over billions of years. Even black holes, once thought to be eternal, gradually evaporate through quantum effects that cause them to emit radiation and lose mass. The phenomenon of proton decay, if it occurs as predicted by some theories of particle physics, would represent the ultimate victory of time's arrow over material structure. Current experiments have established that protons must be stable for at least 1,034 years, but some grand unified theories predict they will eventually decay into lighter particles. If proton decay occurs, it would mean that every atomic nucleus in the universe is fundamentally unstable over sufficiently long timescales, making all matter temporary rather than permanent. The cosmic microwave background radiation provides direct evidence of universal decay on the largest possible scale. This ancient light, released when the universe cooled enough for atoms to form 380,000 years after the Big Bang, has been decaying ever since through cosmological redshift. As space itself expands, the wavelengths of these photons stretch longer and their energy decreases, creating a universe-wide cooling process that has reduced the cosmic background temperature from thousands of degrees to just 2.7 degrees above absolute zero. Stellar evolution demonstrates how gravitational systems participate in universal decay through the process of nuclear burning. Stars maintain their structure by burning nuclear fuel to create radiation pressure that balances gravitational collapse. But this burning process irreversibly converts hydrogen into heavier elements while releasing energy into space. When nuclear fuel is exhausted, gravitational collapse resumes, creating white dwarfs, neutron stars, or black holes that represent different final states of stellar decay. The expansion of the universe itself represents a form of cosmic decay as gravitational potential energy gets converted into kinetic energy of recession. Dark energy accelerates this expansion, causing galaxy clusters to separate ever faster and making the observable universe grow larger and less dense over time. This cosmic expansion drives the universe toward a heat death scenario where all matter becomes so dispersed that gravitational collapse and star formation become impossible. Biological systems demonstrate remarkably sophisticated resistance to decay while ultimately succumbing to entropy increase over longer timescales. Living organisms maintain their complex organization by consuming energy from their environment and exporting entropy as waste heat and chemical byproducts. The DNA repair mechanisms can correct many types of molecular damage, but they cannot prevent the gradual accumulation of mutations over successive generations. Cellular senescence limits the number of times most cells can divide before they lose the ability to maintain themselves against decay processes. The aging process in complex organisms reflects the fundamental impossibility of completely reversing entropy increase in biological systems. While metabolism can temporarily maintain organization by consuming energy and exporting entropy, the molecular machinery that performs these functions gradually degrades through chemical reactions, radiation damage, and thermal fluctuations. Maximum lifespan appears to be limited by the rate at which irreversible damage accumulates, faster than repair mechanisms can correct it. Evolutionary biology reveals how genetic information itself undergoes decay through mutation, while simultaneously creating new complexity through natural selection. Random mutations introduce errors into genetic sequences at predictable rates, creating a molecular clock that can be used to trace evolutionary relationships. Most mutations are neutral or harmful, contributing to genetic decay, but occasionally beneficial mutations arise that increase organism fitness and become preserved through selection. Technological systems exhibit their own forms of decay that mirror biological and physical processes. Electronic devices degrade through electron migration, material fatigue, and thermal cycling. Software systems accumulate errors and inefficiencies through bug accumulation and feature creep. Information stored on physical media gradually degrades through magnetic field decay, optical disc deterioration, and substrate degradation, requiring continuous effort to preserve digital information over long time periods. The second law of thermodynamics guarantees that all energy conversion processes involve some irreversible conversion of useful energy into waste heat. Heat engines cannot achieve perfect efficiency because they must reject some energy to a cold reservoir. Even the most sophisticated machines lose energy to friction, electrical resistance, and other dissipative processes. This fundamental limitation means that perpetual motion machines are impossible and that all mechanical systems eventually stop without continued energy input. The phenomenon of phase transitions reveals how even reversible physical processes become irreversible when viewed over larger scales and longer timeframes. While individual molecules can freely transition between solid, liquid, and gas phases, macroscopic phase changes, like melting or boiling, involve the coordinated behavior of countless molecules in ways that create irreversible increases in entropy. The mixing of different phases or substances creates irreversible changes that can not be undone without external energy input. Crystalline structures demonstrate how universal decay operates even in highly organized systems. Perfect crystals represent minimum entropy configurations, but real crystals contain defects, impurities, and grain boundaries that introduce disorder into the crystal lattice. Radiation damage, thermal fluctuations, and mechanical stress gradually increase the defect density in crystalline materials, causing their properties to change over time in irreversible ways. The concept of decay extends beyond material processes to include the degradation of information and organization. Books yellow and crumble, languages evolve and become extinct, cultures change and disappear, memories fade and become distorted. Even abstract mathematical truths and scientific knowledge require continuous human effort to preserve and transmit across generations. Without ongoing maintenance, all forms of organized information eventually decay into unintelligible noise. But universal decay doesn't represent a cosmic tragedy or fundamental flaw in reality's design. Instead, decay processes create the energy gradients and chemical diversity that make complex phenomena possible. Stellar nucleosynthesis creates heavy elements through decay processes. Radioactive heating drives geological activity that creates diverse planetary environments. Biological mortality creates evolutionary pressure that drives adaptation and complexity increase. Universal decay is the price paid for universal creativity. Understanding decay as a fundamental aspect of reality transforms our relationship with time S-arrow from resistance to acceptance. We are not fighting against decay. We are temporary patterns of organization that emerge from and contribute to the universal decay process. Our existence represents a brief victory of local order creation over global entropy increase, made possible by the same decay processes that will eventually reclaim our organized structure. But to understand how consciousness fits into this cosmic story of decay and creativity, we need to explore how the subjective experience of time emerges from the objective flow of physical processes. Chapter 8. Consciousness Stream. Your consciousness experiences time as a flowing stream of moments, each present experience dissolving into memory as new experiences emerge from the unknown future. This stream feels like the most intimate and undeniable aspect of reality. You are not thinking about the flow of time. You are the flow of time, moment by moment, thought by thought, breath by breath. Yet this subjective stream of consciousness might be the most puzzling phenomenon in the entire universe, creating the lived experience of time's passage through mechanisms that remain largely mysterious to neuroscience and philosophy. The hard problem of consciousness, as philosopher David Chalmers termed it, becomes even harder when we consider time. It's not just that we need to explain why there's something it's like to be conscious. We need to explain why there's something it's like to be conscious right now, in this specific moment, with access to memories of past moments but not future ones. The stream of consciousness doesn't just contain experiences. It creates the temporal structure within which experiences can be meaningful, coherent, and personally continuous. Neuroscience reveals that the brain constructs the experience of present moments through sophisticated integration of sensory information, memory retrieval, and predictive processing. What feels like a simple now actually involves neural processes that occur over several hundred milliseconds, during which the brain combines visual, auditory, and other sensory inputs into a coherent perceptual experience. This temporal binding process creates the illusion that different sensory inputs are simultaneous even when they arrive at the brain at different times. The neuroscientist Antonio Damasio discovered that consciousness depends on the brain's continuous construction of narrative selfhood through what he calls the autobiographical self. This self emerges from the integration of current sensory experience with stored memories about past experiences and anticipated futures. The stream of consciousness flows through this narrative self, creating the sense of being the same person moving forward through time despite constant changes in neural activity and bodily composition. Recent research in neuroscience suggests that consciousness might emerge from the brain's attempt to predict its own future states. The predictive processing theory proposes that the brain continuously generates models of expected sensory input and updates these models based on prediction errors. Consciousness might represent the brain's real-time awareness of its own predictive modeling process, creating subjective experience through the continuous comparison of expected and actual neural states. But the temporal structure of consciousness involves more than just prediction and memory integration. The phenomenology of conscious experience reveals distinct temporal textures that resist simple neurological explanation. The specious present, the window of time that feels immediately accessible to awareness, spans several seconds and can expand or contract based on attention, emotion, and altered states of consciousness. During intense experiences, time seems to slow down, allowing the conscious mind to process more information within each subjective moment. The altered temporal experience during emergency situations demonstrates how consciousness can modify its relationship with objective time. During car accidents, athletes' peak performance, or life-threatening situations, people report experiencing time dilation where events seem to unfold in slow motion. This suggests that consciousness has some control over the rate at which it processes temporal information, creating subjective time that can diverge dramatically from clock time. Meditation and contemplative practices reveal even more dramatic modifications of temporal consciousness. Advanced meditators report experiences of timeless awareness, where the normal flow of thoughts and sensations ceases, and consciousness experiences itself without temporal structure. These states suggest that the stream of consciousness might be more like a river that can sometimes become a still pond, losing its directional flow while maintaining its essential awareness. The phenomenon of memory formation creates one of the most puzzling aspects of consciousness stream. Every moment you experience gets filtered, compressed, and integrated into your existing memory networks. But this process necessarily loses most of the information about the original experience. Your memory of reading this sentence will preserve its meaning and perhaps some contextual details, but it cannot capture the full richness of your current conscious state. This compression creates the sense that past experiences were less vivid and detailed than current experience, contributing to the feeling that consciousness flows from rich present toward impoverished past. Dreams and altered states of consciousness reveal how flexible the stream of consciousness can be regarding temporal sequence and causal logic. During dreams, consciousness can experience elaborate temporal narratives that violate normal causality while feeling completely coherent within the dream state. Past and future can become confused. Impossible timelines can feel natural. And dream consciousness can experience multiple temporal perspectives simultaneously. These states suggest that normal temporal consciousness is just one possible mode of awareness rather than an inevitable consequence of neural activity. The relationship between consciousness and free will become especially puzzling when considered within time stream. Benjamin Libet's experiments showed that unconscious neural activity begins several hundred milliseconds before conscious awareness of intention to act. This temporal lag suggests that consciousness might be more like a narrator commenting on decisions already made by unconscious processes rather than the author of those decisions. Yet conscious intention can modify or veto actions initiated unconsciously, creating a complex temporal relationship between awareness and agency. The integration of multiple sensory streams into unified conscious experience requires sophisticated temporal coordination across different brain regions. Visual processing, auditory processing, and other sensory systems operate at different speeds and require different amounts of neural computation. The brain must somehow align these temporally offset processes to create the experience of simultaneous multisensory perception. This binding problem suggests that consciousness actively constructs temporal simultaneity rather than passively experiencing it. The phenomenon of anticipation reveals how consciousness extends beyond the immediate present to include expectations about future experience. When you anticipate a pleasant event, consciousness experiences a form of temporal pleasure that derives from imagined future states. When you dread future events, consciousness suffers from possibilities that might never actually occur. This temporal extension of consciousness beyond the present moment contributes to both human creativity and human suffering. Language and thought create additional layers of temporal structure within consciousness. When you think in words, consciousness experiences the temporal unfolding of linguistic sequence where each word builds meaning in relationship to previous and anticipated words. This linguistic temporality creates the possibility for complex reasoning, narrative construction, and cultural transmission that extends consciousness beyond immediate sensory experience into abstract temporal relationships. The development of consciousness over the human lifespan reveals how the stream of consciousness changes its temporal characteristics through childhood, adolescence, adulthood, and aging. Young children experience consciousness with different temporal structure than adults, with less clear distinction between fantasy and reality, past and present, self and other. Elderly individuals often experience shifts in temporal consciousness, where distant memories become more vivid than recent experiences, and where the sense of future possibility contracts while past significance expands. Cultural and technological influences shape the stream of consciousness in ways that modify its temporal characteristics. The invention of writing created external memory that allows consciousness to access detailed information about past thoughts and experiences. Digital technology creates new forms of temporal consciousness where attention can be rapidly shifted between multiple information streams and where virtual experiences can feel temporally equivalent to direct physical experience. The mystery of consciousness stream extends beyond human experience to questions about temporal awareness in other animals, artificial intelligence, and potentially even non-biological systems. Do animals experience time's flow in ways similar to human consciousness? Could artificial intelligence develop its own form of temporal consciousness? Might consciousness be a fundamental feature of information processing systems that creates subjective temporal experience wherever sufficient complexity and integration occur? Some philosophers and scientists propose that consciousness might be the universe's way of experiencing its own temporal evolution. From this perspective, conscious beings serve as cosmic sense organs that allow the universe to observe its own development through time. Each stream of consciousness represents a unique temporal perspective through which reality experiences itself. contributing to a cosmic consciousness that encompasses all possible temporal viewpoints. The stream of consciousness reveals time's arrow as more than just an objective physical process. It's the subjective foundation that makes meaning, identity, and purpose possible. Without the temporal structure created by conscious experience, the universe would be a collection of physical events without anyone to experience their significance. The stream of consciousness doesn't just flow through time. It creates the experiential dimension within which time becomes meaningful rather than merely mechanical. Understanding consciousness as a temporal stream prepares us to explore how this subjective experience of time's flow connects to the cosmic origin story that began time itself, the moment when all of existence emerged from a singular cosmic event that established the initial conditions for everything that would follow. Chapter 9. Origin Wound. 13.8 billion years ago, the universe began with a wound that has never healed. In the first infinitesimal fraction of a second after the Big Bang, space, time, matter, and energy all erupted into existence from a state that physics cannot describe or understand. This cosmic origin represents more than just the beginning of everything we observe. It created the fundamental symmetry between past and future that drives time's arrow throughout all subsequent history. The universe bears this origin wound like a scar that determines every aspect of temporal reality, from the expansion of space to the formation of memories in conscious minds. The Big Bang wasn't an explosion that occurred at a particular location in pre-existing space and time. Instead, it represents the sudden appearance of space and time themselves from a state of existence so alien to normal physics that our mathematical languages cannot even formulate meaningful questions about it. Before the Planck epoch, the first y-43 seconds after the beginning, the concepts of space, time, causality, and physical law break down completely. The origin wound exists at the boundary between existence and non-existence, between something and nothing, between possibility and actuality. The physicist Roger Penrose demonstrated that the Big Bang represents the most improbable event in cosmic history from the perspective of entropy and thermodynamic probability. If the early universe had randomly explored all possible configurations with equal probability, it would almost certainly have begun in a state of maximum entropy, a chaotic thermal soup with no structure and no potential for future development. Instead, the universe began in an extraordinarily low entropy state with almost perfect uniformity and vast potential for structure formation. This cosmic fine-tuning creates what Penrose calls the past hypothesis, the assumption that the universe began in a highly special, low entropy condition for reasons we don't understand. The inflationary epoch that occurred during the first tiny fraction of a second after the Big Bang reveals how the origin wound created the large-scale structure of space and time. During inflation, space expanded faster than the speed of light itself, stretching microscopic quantum fluctuations across vast cosmic distances. These stretched fluctuations became the density variations that would later collapse into galaxies, stars, and planets. The origin wound thus created both the homogeneous background of cosmic space and the inhomogeneous seeds of all future complexity. But inflation raises profound questions about the nature of time's beginning. If the inflationary epoch began from an even earlier state, then what caused that earlier state? The eternal inflation theory suggests that our Big Bang might have been just one bubble forming in a vast, cosmic sea of inflating space, with new universes constantly being born through quantum fluctuations. From this perspective, the origin wound that created our universe might be one of countless such wounds in an eternal, ever-expanding multiverse where time has no ultimate beginning. The cosmic microwave background radiation provides the oldest observable evidence of the origin wound, carrying information about the universe's state when it was only 380,000 years old. The tiny temperature fluctuations in this ancient light reveal the precise characteristics of the density variations created during inflation. These fluctuations follow a nearly perfect scale invariant spectrum that matches theoretical predictions for quantum fluctuations stretched by exponential expansion. The origin wound left its signature, written across the entire sky in patterns of ancient light that we can still observe today. The formation of the first hydrogen and helium nuclei during Big Bang nucleosynthesis demonstrates how the origin wound established the chemical composition of the universe. During the first few minutes after the beginning, when the universe was hot and dense enough for nuclear reactions, approximately 25% of ordinary matter was converted from hydrogen into helium, while trace amounts of lithium and deuterium were also produced. This primordial nucleosynthesis ended when the universe expanded and cooled below the threshold for nuclear fusion, freezing the chemical composition until the first stars formed hundreds of millions of years later. The cosmic origin also established the fundamental constants of nature that govern all physical processes. The masses of elementary particles, the strengths of fundamental forces, the rate of cosmic expansion, and the relationship between matter and energy were all determined during the earliest moments after the Big Bang. These constants appear to be precisely fine-tuned to allow the existence of atoms, molecules, stars, planets, and ultimately life and consciousness. The origin wound created not just the initial conditions for cosmic evolution, but the laws of physics themselves. Dark matter and dark energy, which together comprise 95% of the universe's content, represent aspects of the origin wound that remain almost completely mysterious. Dark matter appears to be composed of particles that interact only gravitationally, creating the invisible scaffolding upon which visible matter assembled into galaxies and larger structures. Dark energy drives the accelerating expansion of space itself, causing the universe to grow at an ever-increasing rate. Both dark components were established during the cosmic origin, but their fundamental nature remains unknown despite decades of intensive research. The horizon problem reveals one of the most puzzling aspects of the origin wound. How did regions of space that were never in causal contact acquire nearly identical temperatures and physical properties? The cosmic microwave background shows the same temperature to within 1 part in 100,000 across the entire sky. Yet many of these regions could never have exchanged information, even traveling at the speed of light. Inflation provides a solution by proposing that these apparently disconnected regions were once in causal contact before being stretched apart by exponential expansion. The flatness problem demonstrates another aspect of cosmic fine-tuning associated with the origin wound. The geometry of space appears to be almost perfectly flat, balanced precisely between the positive curvature that would cause the universe to collapse and a negative curvature that would cause it to expand too rapidly for structure formation. This critical balance requires the initial expansion rate and matter density to be fine-tuned to extraordinary precision. Even tiny deviations from this perfect balance would have created a universe that either collapsed immediately or expanded so rapidly that no stars or galaxies could form. The matter-antimatter asymmetry represents one of the most profound mysteries associated with cosmic origin. The fundamental laws of physics treat matter and antimatter almost symmetrically, suggesting that the Big Bang should have created equal amounts of both. Matter and antimatter annihilate when they meet, producing energy but leaving no material particles. Yet our universe consists almost entirely of matter, with antimatter existing only in tiny quantities created by high-energy processes. The origin wound somehow created a small but crucial excess of matter over antimatter that allowed material structures to survive and evolve. Recent discoveries in particle physics and cosmology suggest that the origin wound might involve physics beyond our current understanding. String theory proposes that the Big Bang might represent the collision of higher dimensional brains in a space with more than 3 spatial dimensions. Loop quantum gravity suggests that the Big Bang might be a bounce from a previous contracting phase rather than an absolute beginning. The etbironic model proposes that our universe emerged from the collision of two parallel universes in a higher dimensional space. But perhaps the most profound aspect of the origin wound is its relationship to the arrow of time. The second law of thermodynamics requires that entropy increase over time, but this law only makes sense if the universe began in a low entropy state. The origin wound created the initial conditions that make time's arrow possible by establishing a cosmos far from thermal equilibrium with vast potential for future entropy increase. Without this cosmic wound, time would have no preferred direction, and the universe would exist in eternal thermal equilibrium with no possibility for change, structure formation, or conscious observation. The anthropic principle suggests that we observe the universe's properties to be fine-tuned for life and consciousness precisely because we exist to make these observations. Universes with different physical constants, different initial conditions, or different cosmic histories might exist in vast numbers, but only those universes compatible with the evolution of observers can be observed. The origin wound that created our universe might be just one possibility among countless others, selected for our observation by the requirement that conscious beings exist to study cosmic history. Understanding the origin wound reveals time's arrow as emerging from the universe's memory of its own violent birth. Every process that increases entropy, every structure that forms and dissolves, every conscious experience of temporal flow represents the cosmic wound slowly healing through the gradual approach toward thermal equilibrium. We don't exist despite the universe's traumatic origin. We exist because of it, as temporary patterns of complexity made possible by the ongoing consequences of that initial cosmic catastrophe. The origin wound connects our personal experience of time's flow to the grandest possible context, the emergence of existence itself from primordial nothingness. But to understand whether this cosmic story represents an inevitable fate or a condition that might someday be transcended, we need to explore the possibility that time's arrow might not be as permanent and unchangeable as it appears. Chapter 10. Temporal Rebellion. What if time's relentless forward march isn't as absolute as it appears? What if the arrow of time that seems so fundamental to reality might actually be reversed, stopped, or transcended under the right conditions? Throughout the universe, from the bizarre interior of black holes to the quantum foam of virtual particles, physics reveals tantalizing hints that time's arrow might not be as rigid as our everyday experience suggests. The possibility of temporal rebellion, scenarios where time behaves in ways that violate our normal expectations, opens up profound questions about the ultimate nature of temporal existence and whether conscious beings might someday escape the tyranny of forward-flowing time. The general theory of relativity permits the existence of closed time-like curves, paths through space-time that loop back to their own past. Near rotating black holes called curved black holes, the extreme warping of space-time creates regions where space and time become so twisted that moving forward in space actually carries you backward in time. The Dell universe, a theoretical cosmological model discovered by Kurt Gull, describes a rotating universe where sufficiently distant travel in space would allow you to arrive at your own past. While these solutions to Einstein's equations exist mathematically, they raise disturbing questions about causality and the fundamental structure of temporal reality. Quantum mechanics reveals even more radical possibilities for temporal rebellion through the phenomenon of quantum tunneling across time barriers. Just as particles can tunnel through spatial energy barriers that classical physics would consider insurmountable, quantum systems might be able to tunnel through temporal barriers that separate past from future. Some interpretations of quantum mechanics suggest that particles can take trajectories through spacetime that involve backward time travel, as long as the net effect preserves causal consistency at the macroscopic level. The physicist Kip Thorne extensively studied the possibility of constructing traversable wormholes that could connect different regions of space-time, potentially allowing travel between past and future. While such wormholes would require exotic matter with negative energy density to remain stable, they represent mathematically valid solutions to Einstein's equations. Even more remarkably, Thorne showed that any technology capable of creating traversable wormholes could be modified to create time machines by manipulating the relative motion of the wormhole mouths. But perhaps the most profound challenge to time's arrow comes from the many worlds interpretation of quantum mechanics, which suggests that every quantum measurement creates parallel timelines where all possible outcomes actually occur. If many worlds is correct, then the arrow of time we experience might be just one strand in an infinitely branching tapestry of parallel realities. Other branches might experience time flowing in different directions, at different rates, or with entirely different causal structures. The rebellion against linear time might already be occurring in parallel worlds that we cannot observe. Recent experiments in quantum mechanics have achieved limited forms of time reversal through quantum error correction and information recovery techniques. Scientists have successfully reversed the quantum evolution of small systems, effectively making them younger rather than older on quantum timescales. While these experiments involve only microscopic quantum systems over extremely brief time intervals, they demonstrate that the arrow of time can be locally reversed when sufficient information and energy are available to undo previous changes. The concept of quantum resurrection suggests an even more dramatic form of temporal rebellion. Some cosmological models predict that the universe will eventually reach maximum entropy and heat death. But quantum fluctuations in this dead universe might occasionally create low entropy pockets that briefly reverse local time's arrow. Over vast timescales, these fluctuations might even recreate complex structures like galaxies, stars, planets, and living beings. If this quantum resurrection occurs, conscious beings might experience multiple cycles of existence separated by cosmic ages of non-existence. Artificial intelligence and advanced computation might provide pathways to temporal rebellion through simulation and virtual reality technologies. Sufficiently powerful computers might be able to simulate historical events with perfect accuracy, creating virtual timelines where past events can be revisited, modified, and experienced as if they were real. Conscious minds uploaded into such simulations might experience forms of time travel impossible in physical reality, moving freely between simulated past, present, and future, while retaining continuity of experience. The phenomenon of consciousness itself might represent a form of ongoing temporal rebellion against linear time. During dreams, meditation, and altered states of consciousness, subjective time can slow down, speed up, or lose its normal directional character entirely. Some mystical traditions describe states of consciousness where past, present, and future are experienced simultaneously, suggesting that conscious awareness might have the capacity to transcend ordinary temporal limitations even within current physical reality. Advanced biotechnology might enable forms of biological temporal rebellion through genetic engineering, life extension, and cellular regeneration. If aging could be completely reversed at the cellular level, biological organisms might achieve effective immortality that liberates them from time's arrow, at least in terms of biological decay. Memory enhancement technologies might allow perfect preservation and retrieval of all past experiences, creating forms of consciousness that accumulate rather than forget across vast time spans. The holographic principle in theoretical physics suggests that all information in any region of space can be encoded on the boundary of that region. If reality is fundamentally holographic, then the three-dimensional world we experience might be a projection of more fundamental two-dimensional information. This holographic structure might permit forms of information processing and consciousness that transcend normal temporal limitations by accessing the underlying temporal holographic substrate. String theory's extra dimensions might provide escape routes from ordinary temporal existence through travel in directions perpendicular to normal spacetime. If our three-dimensional space is embedded in a higher dimensional bulk space, consciousness might eventually discover ways to access these extra dimensions, where time's arrow might point in different directions or might not exist at all. The temporal rebellion might involve stepping outside our normal spacetime into realms where causality, entropy, and temporal sequence operate according to entirely different principles. But the most radical possibility for temporal rebellion involves questioning whether time itself is fundamental to reality. The physicist Carlo Rovelli and others have proposed that time might be an emergent property that arises from more fundamental timeless processes. If time is not basic but derived, then sufficiently advanced understanding might reveal ways to access the timeless substrate from which temporal experience emerges. Consciousness might learn to exist in this timeless realm while still interacting with temporal reality. The concept of cosmic consciousness suggests that individual conscious beings might eventually merge into larger collective consciousnesses that experience time differently than isolated minds. These cosmic minds might span vast regions of space and time, experiencing the universe from perspectives that transcend normal temporal limitations. The rebellion against linear time might involve the evolution of consciousness itself beyond individual temporal existence toward forms of collective awareness that operate on cosmic scales. However, every proposed form of temporal rebellion faces fundamental constraints from thermodynamics, causality, and the structure of physical law. The Novikov self-consistency principle requires that any form of time travel must produce logically consistent results that don't create paradoxes. The second law of thermodynamics limits the extent to which entropy can be decreased or time's arrow reversed. The finite speed of light constrains how quickly information and causal influence can propagate through space. These constraints suggest that temporal rebellion, if possible at all, might be severely limited in scope and duration. Local and temporary reversals of time's arrow might be achievable, but global and permanent escape from temporal existence might violate fundamental principles that make coherent reality possible. The rebellion against time might be less about escaping time entirely and more about achieving greater conscious control over the experience of temporal existence. Understanding the possibilities and limitations of temporal rebellion reveals time's arrow as potentially more flexible than it appears, but still constrained by deep principles that preserve causal coherence and logical consistency. The ultimate rebellion might not involve escaping time, but rather learning to work creatively within temporal constraints to achieve forms of existence that transcend normal limitations while respecting the fundamental structure that makes meaningful reality possible. But to understand what this might mean for conscious beings like ourselves, we need to explore how time's arrow is woven into the very fabric of space and reality itself. Chapter 11. Reality Fabric. Space and time are not separate entities that provide a stage for physical events. They are woven together into a single four-dimensional fabric called spacetime that curves, stretches, and flows according to the matter and energy it contains. This spacetime fabric is not merely the arena where time's arrow operates. It is the medium through which temporal asymmetry propagates throughout the universe. Every mass, every particle, every quantum field contributes to shaping this fabric, and every curvature in spacetime influences how time flows, creating a dynamic relationship between matter, energy, geometry, and temporal direction that operates at every scale from quantum foam to cosmic expansion. Einstein's greatest insight was recognizing that gravity is not a force pulling objects together, but rather the curvature of spacetime itself. Massive objects create depressions in the spacetime fabric, and other objects follow the straightest possible paths through this curved geometry, What we experience as gravitational attraction is actually objects following geodesics through warped spacetime, like marbles rolling along curved surfaces. This geometric understanding of gravity reveals that mass and energy directly influence the structure of space and time themselves. But Einstein's theory reveals something even more profound about time's relationship to space and matter. Time flows at different rates depending on gravitational field strength and relative motion. Near massive objects, time runs slower relative to regions of weaker gravity. At high velocities approaching the speed of light, time dilates and runs slower relative to stationary reference frames. These time dilation effects are not just theoretical curiosities. They are measurable phenomena that affect everything from GPS satellite accuracy to particle decay rates in high-energy physics experiments. The fabric of spacetime itself possesses what physicists call grain, a fundamental structure at the smallest possible scales, where the smooth geometry of Einstein's theory breaks down into quantum fluctuations. At the Planck scale, distances of approximately 10 to 35 meters and times of y-43 seconds. Space and time become granular rather than continuous. This quantum foam represents the fabric's finest texture, where virtual particles and antiparticles constantly appear and annihilate, creating a seething sea of quantum activity that underlies all larger-scale spacetime structure. The expansion of the universe demonstrates that spacetime fabric itself evolves over cosmic timescales. The Big Bang wasn't an explosion in pre-existing space. It was the beginning of space itself, which has been expanding ever since. This expansion carries distant galaxies away from each other, not through motion within space, but through the creation of new space between them. Dark energy appears to be accelerating this expansion, causing the fabric of spacetime to stretch at an ever-increasing rate that may eventually overcome all gravitational binding and separate even atomic nuclei. Black holes represent the most extreme warping of spacetime fabric possible within known physics. At the event horizon of a black hole, spacetime curvature becomes so severe that time dilation approaches infinity relative to distant observers. From the perspective of someone falling into a black hole, time continues flowing normally, but external observers would see their clocks running slower as they approach the event horizon, eventually appearing to freeze completely at the boundary. This extreme time dilation demonstrates how the fabric of spacetime can stretch temporal intervals toward infinity. The interior of black holes reveals spacetime fabric in states that challenge our understanding of temporal reality. Beyond the event horizon, the roles of space and time coordinates become reversed. The radial direction toward the singularity becomes time-like, while the temporal direction becomes space-like. This means that once inside a black hole, movement toward the central singularity becomes as inevitable as forward movement through time in normal spacetime. The fabric of reality itself becomes restructured in ways that make escape impossible, even in principle. Gravitational waves, first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO, reveal that spacetime fabric can ripple and vibrate like the surface of a pond. When massive objects like black holes or neutron stars spiral into each other, they create waves that propagate through spacetime at the speed of light, alternately stretching and compressing space itself as they pass through. These waves carry energy and information across cosmic distances, providing a new way to observe the universe through its effects on spacetime geometry. The phenomenon of frame dragging demonstrates how rotating massive objects twist the fabric of spacetime around themselves. Near rotating black holes, neutron stars, or other spinning massive objects, spacetime itself gets pulled along with the rotation, creating a preferential direction for orbiting objects. This dragging effect has been measured around Earth using precision gyroscopes and satellites, confirming that our planet's rotation creates a tiny but detectable twist in local spacetime fabric. Quantum field theory reveals that space-time fabric is filled with quantum fields that permeate every point in space and time. These fields are not merely abstract mathematical constructs. They represent real physical entities that can store and transmit energy and information. Particles are localized excitations of these underlying quantum fields, like waves on an ocean of space-time foam. The vacuum itself is not empty space, but rather the ground state of all quantum fields, containing infinite amounts of zero-point energy that somehow exactly cancel to produce the observed vacuum energy density. The holographic principle suggests that space-time fabric might be fundamentally two-dimensional rather than four-dimensional, with the three spatial dimensions and one time dimension that we experience emerging as holographic projections from information encoded on distant boundaries. This principle arose from studying black hole thermodynamics and suggests that all the information in any region of space can be encoded on the boundary of that region. If reality is holographic, then space-time fabric might be an emergent property of more fundamental information processing occurring on cosmic boundaries. String theory proposes that space-time fabric has additional hidden dimensions beyond the three spatial and one temporal dimension we directly observe. These extra dimensions might be compactified at scales too small to detect, but their geometric properties could influence particle physics and cosmology in observable ways. The shape and topology of these hidden dimensions might determine the fundamental constants of nature and the spectrum of possible particles, suggesting that space-time fabric extends far beyond our direct experience into higher dimensional realms. Loop quantum gravity takes a different approach to space-time fabric by proposing that space and time are fundamentally discrete rather than continuous. According to this theory, space-time fabric is woven from elementary loops and nodes that connect at the Planck scale, creating a quantum network that gives rise to smooth space-time geometry at larger scales. This discrete structure might resolve the singularities that plague general relativity by preventing infinite curvatures that occur when continuous spacetime is pushed to its limits. The topology of spacetime fabric itself might be more complex than the simple flat or curved geometries usually considered in physics. Wormholes could create handles that connect distant regions of space and time. Baby universes might bubble off from our spacetime like foam, creating a vast multiverse of interconnected or isolated cosmic domains. Time loops and closed time-like curves might create regions where spacetime fabric folds back on itself, allowing causal influences to propagate into their own past. The relationship between consciousness and spacetime fabric remains one of the deepest mysteries in physics and philosophy. Some theories propose that conscious observation plays a fundamental role in collapsing quantum superpositions, effectively participating in the creation of definite spacetime geometry from quantum possibilities. Other approaches suggest that consciousness might be an emergent property of certain patterns of information processing within spacetime fabric, arising when the universe becomes sufficiently complex to observe and model itself. The ultimate fate of spacetime fabric depends on the long-term evolution of cosmic expansion, vacuum stability, and the fundamental structure of quantum fields. If dark energy continues accelerating expansion, spacetime fabric might eventually stretch so rapidly that it overcomes all known forces, leading to a big rip scenario where even atoms are torn apart by expanding space. Alternatively, the universe might undergo phase transitions that completely alter the nature of spacetime fabric itself, creating new forms of reality with different physical laws and temporal structure. Understanding spacetime as a dynamic fabric rather than a static stage transforms our conception of time's arrow from a feature imposed on reality to an intrinsic property emerging from reality's geometric structure. We don't move through spacetime. We are temporary patterns woven into spacetime fabric itself, experiencing temporal flow as the universe curves and evolves around us. Time's arrow emerges from the fabric's evolution rather than being separate from it, connecting our personal experience of temporal passage to the cosmic geometry that encompasses all existence. But to understand what this cosmic perspective means for how we should live as temporal beings, we need to explore the deeper meaning of accepting and embracing time's eternal forward flow. Chapter 12. Eternal Flow. Time flows forward like a cosmic river that has been running since the universe began and will continue flowing until entropy reaches its maximum and all possible changes have been exhausted. We are not passengers being carried helplessly by this current. We are drops of water temporarily maintaining coherent patterns within the eternal flow itself. Understanding time's arrow reveals that temporal existence is not a prison to escape, but rather the fundamental condition that makes meaning, creativity, consciousness, and love possible. The eternal flow of time is not our limitation. It is our liberation into the only kind of existence where genuine novelty and authentic relationship can occur. The paradox of temporal existence is that we spend most of our lives either dwelling on the past or anxiously anticipating the future, yet life can only be lived in the present moment. The eternal flow of time means that every moment offers a completely fresh beginning. No matter what has happened before, the next moment brings new possibilities for thought, choice, action, and experience. The arrow of time that seems to limit us by making the past unchangeable also liberates us by making the future genuinely open and undetermined. Buddhist philosophy recognizes this eternal flow as the fundamental nature of existence through the concept of impermanence. Everything that arises must pass away. Every state is temporary. Every configuration of matter and energy is transitional. Rather than viewing this impermanence as tragic, Buddhist thought reveals it as the source of hope and possibility. Because nothing is permanent, suffering states can be transcended. Growth is always possible, and awakening can occur in any moment, regardless of past conditioning. The physicist Carlo Rovelli suggests that time's flow creates rather than destroys meaning by providing the temporal structure within which relationships, purposes, and values can emerge. Without temporal sequence, there could be no causality, no growth, no learning, no love. Memory would be impossible because there would be no past to remember. Hope would be meaningless because there would be no future to anticipate. The eternal flow of time creates the temporal framework within which consciousness can experience itself as part of an unfolding story rather than a static fact. Modern physics reveals that the eternal flow operates through creative principles that continuously generate novel structures and possibilities throughout the universe. Quantum mechanics introduces genuine randomness that creates unpredictable outcomes from deterministic laws. Chaos theory shows how simple rules can generate infinite complexity through sensitive dependence on initial conditions. Evolution demonstrates how random variations can accumulate into organized complexity through natural selection processes that operate over extended time periods. The emergence of life from non-living chemistry represents the universe's discovery of how to use time's flow to create self-reproducing patterns that can evolve increasing complexity over billions of years. Every living organism exists as a temporary eddy in the cosmic flow of matter and energy, maintaining its pattern through continuous exchange with its environment. Death is not the opposite of life, but rather life's way of refreshing itself, making space for new variations and innovations in the ongoing experiment of biological existence. Consciousness represents the universe becoming aware of its own eternal flow through localized patterns of information processing that can model, remember, and anticipate temporal change. Through conscious beings, the universe experiences its own development subjectively rather than merely undergoing it objectively. Every moment of awareness represents the cosmos observing itself from a unique temporal perspective, contributing to a vast collective awakening that spans all conscious beings throughout cosmic history. Human creativity demonstrates how conscious participation in eternal flow can generate genuinely novel patterns that never existed before. Every work of art, scientific discovery, technological innovation, or philosophical insight represents the universe creating something new through human consciousness. We are not separate from natural creativity. We are natural creativity, becoming aware of itself and learning to participate consciously in the cosmic process of novelty generation. Love reveals the deepest significance of eternal flow by creating connections between conscious beings that transcend individual temporal existence. When we love someone, we participate in their temporal experience, sharing their past through empathy and their future through commitment. Love creates interpersonal meaning that emerges from shared temporal existence while pointing toward values that transcend any individual timeline. The eternal flow of time makes love both necessary, because consciousness is temporary, and possible, because consciousness can recognize itself in others. The recognition that we are temporary patterns in eternal flow transforms death from a final ending into a natural transition within ongoing cosmic creativity. Individual consciousness may be temporary, but it emerges from and contributes to processes that extend far beyond any personal timeline. Every thought, choice, and action sends ripples through the causal network that shapes future possibilities for other conscious beings. Physical death represents the dissolution of individual patterns back into the cosmic flow from which new patterns continuously emerge. This cosmic perspective reveals suffering as arising primarily from resistance to eternal flow rather than from the flow itself. When we cling to past experiences, attempt to stop change, or demand that reality conform to our preferences, we create friction against the natural temporal current that carries all existence. Acceptance of eternal flow doesn't mean passive resignation, but rather active participation in ongoing change with awareness that all states and experiences are temporary phases in larger processes. The contemplation of cosmic timescales provides profound perspective on human concerns and achievements. Our species has existed for only a tiny fraction of cosmic history, and individual lifespans represent mere moments in the universe's overall development. Yet this temporal insignificance doesn't diminish human meaning. It reveals how remarkable it is that the universe has evolved the capacity to understand and appreciate itself through conscious beings during our brief cosmic moment. Future cosmic evolution will eventually carry the eternal flow beyond the possibility of consciousness, life, or complex structure. Stars will exhaust their nuclear fuel, black holes will evaporate through Hawking radiation, and the universe will approach maximum entropy, where no further change becomes possible. This ultimate cosmic fate could be seen as tragic, but it reveals the preciousness of the current cosmic era when consciousness and complexity are possible. We exist during the universe's most creative and interesting phase. The eternal flow perspective suggests that the deepest wisdom involves learning to move gracefully with time's current rather than struggling against it. This doesn't mean eliminating goals, plans, or preferences, but rather holding them lightly within awareness of constant change. Every attachment will eventually be dissolved by temporal flow, but this dissolution enables new forms and relationships to emerge continuously throughout cosmic evolution. Meditation and contemplative practice reveal how consciousness can learn to rest in the eternal flow itself rather than getting caught in the contents that flow through awareness. In deep meditative states, the sense of separate self dissolves into direct experience of being the cosmic process rather than being carried along by it. This dissolution doesn't eliminate individual identity, but rather reveals it as a temporary wave pattern in an infinite ocean of conscious awareness. The ultimate teaching of time's arrow is that existence is gift rather than burden, opportunity rather than limitation, creativity rather than mechanism. The eternal flow has brought forth stars, planets, life, consciousness, love, art, science, and every form of beauty and meaning we can experience or imagine. We are not accidents in an indifferent universe. We are the universe's way of experiencing wonder and its own creative capacity. As you continue your journey within this eternal flow, remember that every moment offers fresh possibilities for growth, connection, understanding, and contribution to the cosmic story that encompasses all existence. Time's arrow doesn't carry you toward an ending, but rather through endless beginnings, each moment pregnant with potential for discoveries and experiences that have never occurred before in the entire 14 billion year history of the universe. The eternal flow continues, and you are both its witness and its participant, both its creation and its creator, both temporary and eternal, moving forever forward into the infinite mystery of what comes next. Throughout this journey into the heart of time's greatest mystery, we've discovered that the arrow of time emerges not from a single cause, but from a symphony of interconnected phenomena that span every scale of reality. We've seen how broken symmetry creates temporal direction, how entropy's hidden arrow drives cosmic evolution, how the universe operates as a vast thermodynamic kitchen cooling since the Big Bang. We've explored quantum ghosts that reveal time's strange relationship with observation, memory crystals that connect consciousness to information processing, and the causal prison that gives structure to temporal existence. We've witnessed universal decay as the creative force that makes complexity possible, consciousness stream as the subjective experience of time's flow, and the origin wound that began everything we know. We've contemplated possibilities for temporal rebellion while recognizing the constraints that preserve causal coherence, examined space-time as a dynamic fabric that weaves together matter, energy, and geometry, and finally recognized eternal flow as the fundamental condition that enables meaning, creativity, and consciousness itself. But perhaps the most profound insight is that time's arrow doesn't limit existence. It creates existence. Without temporal asymmetry, without the irreversible increase of entropy, without the forward flow from organized past toward more dispersed future, there could be no structure, no process, no story, no consciousness, no love. The universe would exist in eternal thermal equilibrium, perfectly balanced and perfectly sterile, with no possibility for change, growth, or novelty. The arrow of time is not humanity's burden to bear, but rather the cosmic gift that makes everything meaningful possible. Every memory you treasure exists because information can crystallize in permanent forms. Every hope you cherish depends on a future remaining genuinely open and undetermined. Every relationship you value emerges from conscious beings sharing temporal experience within the flowing stream of moments. Every creative act you admire represents the universe discovering new possibilities through conscious participation in its own evolution. As you move forward into your own temporal existence, remember that you are not separate from the cosmic processes that create time's arrow. You are those processes, temporarily organized into conscious patterns that can experience wonder at the universe's creativity. Your consciousness represents the cosmos becoming aware of itself. Your choices contribute to the cosmic evolution of possibility space, and your love connects individual temporal streams into larger networks of meaning that transcend any personal timeline. The broken symmetry that began with the Big Bang continues in every decision you make that selects one path through possibility while closing others. The entropy increase that drives cosmic evolution accelerates through every memory you form, every thought you think, every action you take. The quantum measurements that collapse ghostly possibilities into definite realities occur continuously through your sensory, experience, and conscious attention. You are not witnessing time's arrow. You are helping to create it. The causal prison that seems to constrain temporal existence actually provides the framework within which genuine choice becomes possible and consequential. Without causal structure, your decisions would have no lasting effects, and your actions would make no difference to future possibilities. The prison is also the platform from which meaningful influence can propagate through space and time, connecting your individual existence to the vast network of cause and effect that shapes cosmic evolution. Universal decay might seem like cosmic tragedy, but it provides the energy gradients and chemical diversity that make life and consciousness possible. Without stars burning nuclear fuel and radiating energy into cold space, without radioactive elements creating heat in planetary cores, without cellular metabolism converting chemical energy into biological organization, there would be no complex structures capable of experiencing beauty, understanding, or love. The consciousness stream that creates your subjective experience of time's passage connects you directly to the fundamental mystery of how awareness emerges from physical process. Every moment of conscious experience represents the universe observing itself from a unique perspective, contributing to a cosmic awakening that spans all conscious beings throughout space and time. Your individual awareness participates in this universal consciousness while remaining irreducibly personal and creative. Even if temporal rebellion becomes possible through advanced technology, conscious evolution, or deeper understanding of reality's structure, the goal would not be to escape time, but to achieve greater harmony with temporal existence. The eternal flow of time creates rather than destroys the possibility for growth, relationship, creativity, and meaning. Learning to move gracefully with this flow, rather than struggling against it, reveals existence as gift rather than burden. The reality fabric of space-time connects your personal experience to the cosmic context that encompasses all existence. Your consciousness emerges from and participates in the geometric evolution of the universe itself. Every thought patterns space, every emotion colors time, every choice contributes to the ongoing creation of the cosmic story that includes all possible forms of beauty, truth, and love. If you found yourself moved by this exploration of time's deepest mysteries, take a moment to subscribe and give this video a thumbs up. Consider sharing your thoughts about your own relationship with time's flow in the comments below. How has understanding time's arrow changed your perspective on existence, consciousness, or your place in the cosmic story? For those hungry to continue exploring the deepest questions about reality, check out my video on the nature of consciousness and its relationship to quantum mechanics. I think you'll find it expands on many themes we've touched on tonight in fascinating directions. The eternal flow carries each of us forward into moments that have never existed before in the 14 billion year history of the universe. Every sunrise brings genuinely new possibilities for discovery, connection, creativity, and growth. Every breath participates in the cosmic circulation that connects your individual existence to the vast processes that create and maintain reality itself. Time's arrow doesn't carry you toward an ending. It carries you toward endless beginning, infinite possibility, eternal creativity, and the ongoing miracle of existence becoming aware of its own wonder.